Good morning. And if it's not a good morning, just morning. For those of you who haven't woken up yet, it's just morning. For those of you who like to get up at the crack of dawn, it's a really good morning. And for those of you who do like getting up at the crack of dawn, could you please just keep your excitement to yourself for those of us who don't like to get up that early in the morning? I am that reluctant morning guy because sometimes, a kid will jump in on the bed and wake me up. And of course, I'm like, play that game. So we have different times that we get up. We're all starting here at about 8:30 this morning. So it is a morning or a good morning for all of you. Welcome to the second day of the conference. If you were here yesterday, you know that I'm Tom Dykstra. If you weren't here yesterday, I'm Tom Dykstra. So this is now as I mentioned yesterday, this is now the fifth talk dealing with this whole insect Brix sugar situation. This talk, as I alluded to yesterday, is designed in order to start filling in some gaps. Some of the gaps that are often come from questions from the audience when I'm presenting. I also like to fill in particular details so that you have a stronger understanding of what we are talking about when we deal with sugar, because the concept of sugar is paramount in agriculture, despite the fact that most people don't talk about it. The reason why it's paramount, I alluded to yesterday. By the time this presentation is done, once again, I am going to beat it into you about how important sugar is in agriculture, and therefore give you that broader understanding, in some cases a specific understanding, because I am going to get into some specifics. Not because I expect you to necessarily memorize it, but I need to give you some background information, some specific background information, so that you can understand how all of this comes together. So as I mentioned yesterday, the second presentation was done yesterday. I do have a first, a third, and a fourth. Some of them might be on the internet, some of them may not be. I don't think the third one is yet. But right now, you have now got the opportunity to see two of them. If there are some gaps, they may have been answered in the third and the fourth. I will answer them when you ask a question at the end. So if I am leaving something out and it seems obvious to you, that's simply because I'm throwing together some information, dare I say, from the first four presentations, which are kind of in my mind, may not be in yours, and therefore I will just kind of skip through if I feel like I've covered it before. So this talk is, as I mentioned yesterday, it's brand new. So this is a brand new talk. I have not presented this before, which means you have the benefit of hearing the worst sugar and agriculture talk that I will ever give. Because I swear to you, the second and the third time that I give this, I will make improvements upon it. But because Cindy has been such an integral part of this Brix journey, I usually try to the best of my abilities to give her a nod when she asks for a brand new presentation. Are you feeling better now, Cindy? Absolutely, if they can hear you.
In every one of your little black bags, there is a little sample of the jaggery, and if you notice the label on it, it goes exactly with this presentation. So if you're looking for a good sugar source, as Tom's talking to go in your coffee, you've got sugar in your bag, and it's all connected to this presentation.
Wow, there's more sugar in this conference than I thought there was. I remember opening up the bag, looking in and thinking, man, this looks like sugar, but it can't be. And then it was confirmed to me, oh yeah, this is sugar. And I thought, all right, how appropriate that I do this right now. So the title of the talk is Sugar in Agriculture. That's the main title of the talk. You can see that I have a subtitle, From Carbon to Brix, because sugar is integrally related to carbon. Glenn spent some time yesterday, wonderful presentation, talking about the importance of carbon. And because it is important, I am going to be talking about a little bit about the importance of sugar as it relates to carbon, because it's a carbon source. In addition to the carbon, I will also be talking a little bit more about the Brix situation. I need to discuss how sugar is moving around the plant, give you guys some idea, because I often get questions all the time. People are still not understanding the concept of leaf Brix, and sometimes I have to open up a little bit and talk a little bit about things moving around the plant and how you can measure different parts of the plant if you want. If you don't want to do that, I'm going to do a little bit of the work for you and give you a little bit, a few data points to just wet the palate on this morning, because I'm just warming up with the speakers behind me. Sugar and agriculture, from carbon to Brix. Let's begin with photosynthesis. Why? Because this is why I'm up here talking about sugar. It is the most important thing for a plant. A plant's job is to make sugar. This is the end game. The end game for the plant, not the movie. Great movie, by the way. Really enjoyed watching that with my kids. So because of this, we've got the photosynthesis process, which takes CO2 and water and turns it into C6H12O6, which is sugar. And we also get some byproduct out the back, which, believe it or not, is oxygen. So that's actually a waste product for the plant. So this is the reaction. This is what makes the world go round. This is what gives the plant all that it needs, the energy that it needs, the structure that it needs. And we cannot underestimate the importance of sugar. When you start underestimating the importance of sugar, you start underestimating the importance of carbon, and you start underestimating the importance of Brix, and then you start underestimating the information that you should have about your plants that you do not have. And the quickest way to determine plant health is to test plant sap with a refractometer. Are you in a hurry? I'm in a hurry. We're all in a hurry. You want an answer quickly. You can do this in your field. You don't have to take the leaves, put them into a bag and send them off and pay $50, $100, sometimes $300 to get various analyses from it. You've got the answer right now. You're looking at the plant. You assess the plant. You take a Brix reading. You get immediate feedback, because you'll be looking at it thinking, wow, this looks pretty good, and then it comes out at a 5, and you think, okay, so this is what a 5 looks like. And then when you see, oh, wow, this plant looks even better than the last one, and they measure it, and it comes in at 10. And you say, aha. So you're starting to make connections. Farmers need to make these connections. I need you guys to make these connections, because when you come up to me, or even Glenn, we are going to ask if you have any Brix readings for us. I kind of want to know where we're starting from. There's a big difference if we're starting at 2. But if you're coming in at 9, this changes things. So I am looking for some information from you. And because it's so inexpensive, the refractometer is running about 20, 25 bucks on Amazon right now. There's really no excuse, financially speaking, not to use one. Now, if you don't use one, there are a lot of farmers that might be a little bit on the lazy side. They're not that interested in doing it. Not you, of course, but other conferences where I have to deal with that. You guys are on the ball. Most of you on the ball. At least, yeah, morning hours on the ball. So because of that, the refractometer is going to be your best friend. The Brix refractometers do take 2 types. We have the one that Glenn showed you yesterday. That's where you lift up the flap right there and put 2 or 3 drops on that. That is the eyepiece right there. Look at it through a light source. You can look at it through a light source here if it's indoors, or you can take a look at the sun. Don't have to be looking directly at the sun. You just need to kind of go in that general direction, and you should have enough light coming in order to measure and find out where the line is, which you can estimate to the nearest 0.5 Brix, usually, if it's not too fuzzy. The one on the right, that's the one I like, because I'm a digital guy. I'm comfortable with batteries. If you are not technically savvy, if you put in batteries upside down all of the time in every single device that you use, this one is not for you. This is way above your pay grade right now. But for those of you who can handle batteries and can put them in exactly the right way, this one is for you, and it's for me because it's quick. It's easy to clean. And I get a reading to the nearest 10th. So cool. 12.3. So that I can distinguish between a plant that's at 12.2. The real difference between them, totally insignificant. But to me, a scientist, I'm like, yeah, 1 up 0.1. And everyone looking around thinking, yeah, loser. But I am a nerd, and that's why I don't get invited to parties too much. All right, photosynthesis. Photosynthesis is occurring inside the leaf. It is inside the leaf, and I mean literally inside the leaf, because we have an epidermal group of cells on the top of the leaf. We have epidermal cells on the bottom of the leaf, and they do not photosynthesize. There are a few exceptions, but generally they do not. It's the ones in the middle. The palisade cells here, the spongy mesophyll layer here. These are all chloroplasts, these green structures. The chloroplast is where photosynthesis takes place. Because it takes place in the leaf, you now know why I test leaf Brix. I want to know where the sugar is, where it's being produced. That's going to give you the most reliable figure that I can get. And there are a lot of those chloroplasts. Those chloroplasts are there in order to make as much sugar as possible. If they are lacking in chloroplasts, they are usually dealing with a low Brix plant, a low Brix situation. If there are a lot of them, that's because the plant is relatively healthy and is doing the job that God intended it to do, which is to make sugar for itself and for root exudates or for anyone else who happens to be eating in the plant, should any of you be salad eaters out there. All right, so yeah, we squash the leaf, get a few drops from the liquid mash that we get, and then we are in business. Now, the importance of sugar cannot be understated. I mean, golly, I'm spending an entire talk just dealing with sugar. But part of the reason why it's so important is because, I wouldn't say most, because it's averaging about 40%, but about half of the sugar that the plant makes, it gets rid of. I just got finished telling you that sugar was the most important thing for a plant to do. I just got finished telling you that. And now I'm telling you that about half of it is expelled, never to be seen again. You must also start to think, well, if God intended photosynthesis to occur, and a lot of it is being expelled, there must be a good reason for that. And there is. It's to feed the microbes. So a lot of the sugar is sent down into the roots, mostly at night. It can happen during the day too, don't get me wrong, but a lot of it occurs at night after the photosynthesis is done, and they start feeding the microbes in the soil because they need a sugar source, a carbon source. And it varies. It's averaging about 40% though, but it does vary. And so you can get variability between 20 to 70%. A plant that is low Brix is probably going to be in the 20 to 30% range. There will not be as much sugar coming out of the root exudates because it's a low Brix plant. This is going to compromise your plant, compromises the soil. Everything is compromised, and this is why we start bringing in emergency measures in order to take care of problems, such as the pesticides, such as the NPK fertilizers, because we're force feeding the plant right now with those things due to the high electrical conductivity. I think Glenn mentioned that yesterday. Electrical conductivity, that's another talk as well. And so here we are. You see the importance of why this sugar needs to go down. It feeds the microbes because the microbes feed the plant. The plant is, believe it or not very good at feeding itself, because if you take away all of the microbes, plants suffer horribly. They do survive. We do have some situations where they can struggle, but they really need those microbes. Those microbes, if they're not in the soil, sometimes they need to be inside the roots, but those microbes need to be fed. The nitrogen nodules on soybean, holy smokes. Rhizobia, they love sugar. They take more sugar than some of the other The nitrogen-fixing bacteria really like sugar. And so because of this, they also need to be fed. So here's photosynthesis occurring. We know that these are all solar collectors. That's the reason for the leaves. And we know that once the sugar is made, the sugar now passes down the plant, as I mentioned, at night into the rhizosphere, the root sphere. And once it does that, the sugar is then usually migrates a little bit out away from the roots, starting to feed a lot of the microbes that happen to be in the soil. Often, trying to bring them in to the roots so that they can remain in close association. The plant will give them sugar, and they expect to get manganese back, or cobalt back, or iron back, or copper back. A lot of these micronutrients, these will take care of the plant as long as they are being fed. And they need to be fed by a higher Brix plant. Otherwise, there won't be that much microbial activity, and you will then be dealing with a low Brix plant on your refractometer. So up in the sky, we've got CO2. So there's a lot of CO2 up there. Or is there? There is not enough CO2 in the atmosphere. Yeah, another heretical statement. You're welcome. Plants cannot survive at the current levels of CO2. There's not enough. They must have another source because they cannot get all of the CO2 through their leaves. So the CO2 is brought into the leaves and it makes sugar. This sugar I just mentioned is being used to feed the microbes. Most of the microbes, probably 80% or more, are aerobic. Because they're aerobic, they are taking in, they're respirating, they're taking in oxygen like we do, and then they expel carbon dioxide. Now we have another source. So in this system, we've got about 425 parts per million in the atmosphere right now, which I'm sure you've all heard is going to kill us. It will kill us all. Good luck. Pleasure talking to you. Probably won't see you next year. In the Ordovician Cambrian explosion, where life exploded, there are estimates that are as low as 4,000 parts per million. They were as high as 8,000 parts per million, and during that time, plant growth was lush. Very, very lush. That's the level that plants would be looking for if they can get it. And some of those plants, we've all seen the pictures of the dinosaurs and their big plants around them. We've seen them on the fossils, some of the size of these leaves. These were very, very big plants. And so that's what plants are looking for. So they're all deficient in CO2. If they do not get enough CO2, they will not be able to photosynthesize well. And since they're not getting it from the air, they've got to be able to get it from the soil. So all the microbes, the aerobic microbes in the soil are respiring. They are expelling CO2 after taking in oxygen. The levels in the soil are between 500 to 5,000 parts per million in the soil. Now, we've got a real source of carbon dioxide that the plant can use. Unfortunately, if you're thinking ahead and you've woken up yet, some of you have, some of you have not. For those of you who haven't woken up, I will spoon feed it to you right now. The CO2 needs to get up to the leaf. It's in the soil. How does it get up to the leaf where the plant can actually use the excess CO2 above and beyond the 425 parts per million right now? Glenn told you yesterday. Do you remember what Glenn said about how CO2 gets up? He was talking about meteorology. And in the process of meteorology, they have fronts. And these fronts come in often bringing rain. Sometimes they bring snow. But these fronts are high pressure fronts and they're low pressure fronts. When a high pressure front comes in, the high pressure pushes the atmosphere into the soil as far as it can go reasonably, assuming you don't have compacted soil, and pushes the atmosphere in for two very important molecules. One is oxygen, so that the aerobic bacteria can get oxygen and it's forcibly pushed in. And the second one is to get, what's actually water too, and the second one is nitrogen. So a lot of the nitrogen is also pushed into the soil. Therefore, the nitrogen-fixing bacteria are able to make nitrogen. Then we have a low front. The low front comes in. It doesn't push things down. It's now pulling things up. And is this process of a low front that brings up the accumulation of that between 500 to 5,000 parts per million CO2, and it moves it up directly underneath the plant and the plant sucks it in through its stomata. This is part of the reason, God bless you, this is part of the reason why a plant healths up right after a rain. We think sometimes, and we're right, that it is the rain itself, and you would be correct. It's good, healthy water. Some of you also know that it brings in ions, also healths up the environment. You'd be right about too. But it also, when the rain comes in and with these high and low fronts, it brings the CO2 up. It pushes oxygen down, brings the CO2 up. The plant breathes, and we get a massive growth of green right after a rain. So I just gave you 3 reasons why rain is so good. It is far superior to irrigation. This is part of the reason why rain water is better for your plants than irrigated water. Many of you have wondered about this before. I'm trying to answer it right now. That's why irrigated water is always inferior, because it's not as good as what God has designed, and therefore we are now dealing with a more healthy situation. And the Brix levels go up after a rain for some of these reasons that I just mentioned. CO2 is then taken in through those stomata. Those are the small holes on the bottom of the leaves. They are strategically located on the bottom. You ever thought about that? They're located on the bottom because the extra CO2 is coming up. Otherwise, they might have the stomata on the top. But they have them on the bottom because they're looking for that CO2 from the microbes, which should be in plenitude in the soil. And that makes sugar. Sugar is a 6-carbon ring, and all photosynthesis directs itself to the production of sugar, but specifically glucose. There are many types of sugar out there, but there's only one that photosynthesis makes, glucose. Not the others, just glucose. Where am I going with this? Follow me. This glucose now sometimes can be changed into fructose. Fructose is something we've heard before, high fructose corn syrup, for example. Fructose, many people consider to be bad. And now I'm telling you that the plants are making this in plenitude. Is it really that bad? It's not that bad at all. We are able to digest glucose. That's our main sugar. We are also able to digest fructose. The only problem people are having with fructose is that it's in higher concentrations than our bodies are used to. That's really the danger of the high fructose corn syrup, not the fact that we can't digest it, not that it's some evil substance. It's simply part of the process, and it's an important part of the process because when glucose and, glucose isomerase, it's a big word right now, but it is an enzyme that converts glucose to fructose. This is an important enzyme as far as the Brix refractometer is concerned, because we need fructose in the plant to be made. And the glucose isomerase has some cofactors. Magnesium. If magnesium is not available, it uses manganese. If manganese is not available, the third choice is cobalt. These are the cofactors that make it happen. If we have a shortage of magnesium, and sometimes we do, high mag soil is obviously not, but in Florida, we deal with a massive amount of calcium, and we do have magnesium deficiencies. If not, it can use manganese, but manganese is being chelated by glyphosate, and cobalt is found in very low numbers and is really not reliable. So we have a potential problem where not enough fructose is made from glucose. Why is that a problem? Because when glucose and fructose come together, it makes sucrose. Sucrose is a 2-sugar molecule. It's made of 1 glucose and 1 fructose. And this molecule right there, sucrose, is the storage form of sugar in a plant. That is the end game for most of the plants. It doesn't store glucose well. It doesn't store fructose well. There can still be a considerable amount of the 2 sugars moving around the plant. But the end game is to bring them together, which you cannot do without glucose isomerase, turn it into sucrose, And now we have the storage form of sugar that we are all testing with the refractometer. Why is this important? This is important because, do I have the, yeah. This is table sugar. Can't remember if yep. This is table sugar. This is what the refractometer is calibrated to. So it's very wisely done to this, because when you are testing the leaf with the refractometer, it is designed to test sucrose because it's the #1 sugar inside plants. It is the storage form. So it makes sense that the refractometer should be calibrated to sucrose. Because it's not calibrated to glucose or fructose, is this a big deal for you? Absolutely not. When you measure the refractometer and you get a reading, it's mostly sucrose, but you're also detecting glucose and fructose. It's not a big deal because there is going to be a little bit of the 2 monosaccharides there. But it is a big deal for some people. I am now taking care of a complaint that I have often received, and that is very smart people come up to me and go, "What's the sugar for photosynthesis?" I said, "Glucose." "Yeah." "And the refractometer, what is that calibrated to?" I'm like, "Sucrose." They're like, "Ha ha." So are you really testing photosynthesis, doc? You really know what you're doing? And I would say, all right. The difference between measuring sucrose, glucose, and fructose with a refractometer is not important enough for you to worry about. It's important enough if you are a scientist in a laboratory with a lot of expensive equipment, and you want to be able to know to the nearest 10th or the nearest 100th what the refractometer is telling us about each one of those sugars. Then it becomes important. But when I'm talking to farmers, I don't care about it. You don't care about it. So when you start to get attacked, and you will, by people who think that they're smarter than you, you run into problems like this. Thus, the reason for this 5th talk. So you must understand the refractometer is calibrated to sucrose. You must also understand that you're testing a little bit of glucose and fructose in the plant too. Not anything to get your panties up in a wad, okay? This is a natural process, okay? You're testing all 3. You're testing all 3. You need to know that. But it's calibrated to sucrose because that's the storage form. All right, I think I've beaten that to death right now. Let's move on. Over here, we have different sugars. I've got the monosaccharides on the top right there. I've got fructose, galactose, and glucose. I've already talked about 2 of them. I've already talked about sucrose, which is 2 of them come together. There is also raffinose. It's a trisaccharide, which sometimes you will find moving around a plant. Don't get excited. Refractometer can take care of these things too. And then over to the right, we have cellulose. Cellulose. Cellulose is the main structure that plants are made of. Trees are made of cellulose. Plants are made of cellulose. They're all made of cellulose. There's more than that. There are some nitrogen cross-linkages, though, but basically cellulose runs the show. Cellulose is the structure of plants, and it is composed of repeating glucose units. So when Glenn Rabenberg talks about the C6H12O6, the carbon, the hydrogen, nitrogen, the plant is made of the same stuff. It's made of the carbon, hydrogen, and oxygen. I'm now giving you the reason why. Because every plant is composed of repeating glucose units. There's very little fructose involved in this type of thing. It's repeating glucose units. This is what gives the structure, the leaf, the stem, the roots. These are all composed of cellulose. So the plant is making sugar. A lot of it is kept for itself in order to grow. The plant grows because of photosynthesis and takes this sugar and turns it into plant matter, the stuff that we see. A lot of it does go to the roots, but a lot of it is kept for itself. That is the actual structure. That's the reason why carbon is so important. We need a lot of carbon, otherwise we don't get healthy plants. And the only way to get carbon is through CO2. because the CO2 is the only carbon part that is incorporated into sugar. I'm a big advocate of putting sugar down into the ground. No, it is not being measured on the refractometer. It is done in order to feed the microbes. I'm simply doing what the plants do naturally. So how many times have I been attacked? I was like, okay, doc, so you're telling them to put sugar down, a little bit of molasses, huh? And then you measure it and the Brix goes up. Hello, you just put sugar down. You're just measuring the sugar. Plant hasn't changed, it's not any healthier. And I gotta go, all right. The sugar that you put down is feeding the microbes. It is not getting into the plant. Radio labeling shows it's not getting into the plant. All of the sugar inside the plant comes from CO2. The more CO2 you have, we can't control the atmosphere very well, although some will claim we can, but we can control the microbes, and we can increase the CO2 level, and that makes for a healthy plant. So cellulose is the structure. That's why we have so much carbon, hydrogen, and oxygen. It is all related to that, and now you've got a stronger reason why, because it's all related to sugar. So here's the photosynthesis formula again for clarification. And down here, I'm showing you some of the minerals which are very, very important for photosynthesis. If you have a shortage of manganese, magnesium, phosphorus, nitrogen, iron, and calcium, your photosynthesis will go down. When your photosynthesis goes down, you get lower Brix plants. When you get lower Brix plants, you're not raising the healthy plants that you want anymore. We cannot have deficiencies of this. Calcium is certainly talked about in plenitude at these conferences, especially because Glenn uses such an important molecule. Did you know that there is a massive concentration of calcium in the chloroplasts? I told you how the chloroplasts are photosynthesizing. They need a lot of calcium in order to photosynthesize. I think the calcium in the chloroplast is either second or third. It's, of course, way behind the central vacuole, but there's a lot of calcium there, and that is required. So when we talk about the importance of calcium, or Cindy talks about the importance of calcium, or Glenn talks about the importance of calcium, this is part of the reason why, is because photosynthesis is very related to it. Magnesium, for example, many people know in the middle of the chlorophyll atom, we have magnesium. So I'm not going to go into all of them, but they all have a massive importance in photosynthesis, and that's why we want them to be there in relative plenitude, or to be bioavailable. So photosynthesis leads to sugar. And sugar leads to other carbonaceous compounds. So the carbon that is in there is being used to make cellulose. I already talked about that. That's a carbonaceous compound. But we've got all of this carbon in the air, carbon turned into sugar, carbon being turned into other forms of carbon. It's carbon, 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 carbon. You see the importance of carbon. So when Glenn is talking about 8-to-1 carbon and nitrogen is not enough, this is part of the reason why. This is why he said 16-to-1 is at the beginning stages of health, and how we're really going to be looking for 20 to 24-to-1, and how our compost is 30-to-1. We need a lot of carbon. And that's why yesterday he was saying when you have a carbon deficiency, you have problems. And based upon the slides that I'm showing right now, this should become clear in your mind why he's right. I will not repeat that again, Glenn.
I'll remember it.
You will, but you don't have me recorded right now, and they're not going to release that to you because I asked them not to. So up here, there are lots of Brix charts that are on the internet, and they will tell you what the readings are for poor, average, good, or excellent. So there's a lot of information. Brix has been around for much longer than Tom Dykstra, and so these charts existed long before I came into the picture. So you will notice at the top, the reason why I put it up there is because it says calibrated in percent sucrose, or Brix. So the information is out there. I'm not showing anything new. Yes, it's calibrated to sucrose. So it's on the charts. I'm telling you it's this way. I just wanted to make sure that you have enough information that you can handle the hecklers that will sometimes take a shot, pot shot. All right. I want to talk a little bit about sugar as it's moving around the plant. I do spend a lot of time talking about leaf bricks. The chart that I have is about leaf bricks. But sugar is moving around the plant too in other areas. You've got the root bricks, stem bricks, fruit bricks, phloem bricks. And so here we've got some leaves, big leaves. I usually measure 30 leaves at a time for statistical significance. For a plant like ginger, 30 leaves, good golly. I don't need that much. I could use half a leaf or a quarter of a leaf and get what I need. But sometimes we do have some plants with very, very big leaves. And so there are some massive ones right there. Root bricks, we can measure the roots too. Of course, we do that in carrots. When we're measuring root bricks, we are simply squashing and getting the juice out of the roots. However, you can still use the leaf of the carrot in order to take a look to see how healthy the plant is. Because the leaf bricks will give you a more accurate measurement. The root bricks is not as accurate because there's some fluctuations that occur. For example, when a carrot is just starting out, it's at a low bricks, and then as it gets bigger and sugar starts accumulating in the roots, which gives it that sweetness to it, then the bricks goes up. That's why I always urge you to measure the leaf bricks. But you can measure different parts of the plant. So for those of you who are interested, you can do so. Stem bricks, sugarcane. We've got sugarcane in Florida. So we measure the stem there because that's where the sugar is located. Fruit bricks, of course, oranges that I discussed yesterday. And we also have phloem bricks. We have a process now called plant sap analysis, a method that can actually extract the phloem and the xylem tissue of the leaf. And during that measurement, there is a sugar reading that comes from it. How many times have I had to field that question? So I'll talk to you a little bit about phloem bricks, and that will be pretty much near the end. So we've got these different types of plant parts, all with different types of sugar. I just want to give you the briefest introduction to all of them so that you become more informed about how this process of sugar all comes about. All right, leaf bricks. The leaf bricks I already showed you. This is the chart. This is the chart that I showed you yesterday. This is the chart that I'm showing you again. I'm not going to go through it in detail because you've seen what this chart is, and I've talked about it in sufficient detail. This is leaf bricks. This chart applies to the leaf part because if you start measuring other parts, some roots, some stems, some fruit, you can easily break 20 bricks. And that's what I'm trying to have you avoid because I'm trying to prevent confusion. Because many people will start to measure different parts of the plant and they get messed up. Stick with the leaf, you're going to be in good shape. But if you decide to go out a little bit further, yeah. So this was talked about yesterday. I was talking about it at the table, so I decided to throw in the slide. This is a soybean plant. It is being attacked by the soybean aphid quite readily. This is GMO soybean. You can see the aphids attacking it. That's a lot of their dead bodies, their skins, their molted. That's the white stuff right there. The green ones right there are that's Aphis glycinus, which is the soybean aphid. So they are attacking this soybean leaf. This trifoliate leaf is being attacked quite readily by the soybean aphid. This is a 3 to 5 bricks plant. You will notice that the leaf is about 3/4 the length of a man's finger. That's about the size of a leaf. And that's what you're usually getting when you're dealing with the 3 to 5 bricks. Many of you, this is what you see if you've ever raised soybeans before, because 94% of the soybeans are GMO. If you're using a non-GMO plant, the soybean looks different. Okay? Here's an example of it right now. We're now taking at a leaf. This leaf in particular is at 12 bricks. Not as high as I would like it, but it's reasonably high. This leaf is it's gigantic compared to the other one, but it's just a normal size soybean leaf. This leaf is about 3/4 the length of a man's palm. The others are about 3/4 of the length of a man's finger. I'm not going to put the middle finger up right now. You get the idea. This is a family show. But I am putting up the palm right now to show you the size of the hand and how big this leaf is, and it's only coming in at 12 bricks. You'll also notice it's not being attacked by any insect too. And it also looks like the leaf looks really healthy. And if you look really, really, really close, and you're probably not able to see that in the back, the stem of the soybean is considerably thicker than the one on the right has a thicker stem than the one on the left. So I just wanted to give you a little bit of background is that you can, while you're measuring and using the refractometer, you can actually learn a lot by just using your eyes. What did Glenn say? You know, see through your eyes, listen through your ears. I'm adulterating it, and I'm sorry that I'm adulterating it, but you get the point that I'm making is make sure that you're paying attention to what you're looking at and what you're seeing and hearing, because this is a very strong difference in soybean about what's capable and what we are dealing with right now. This is the majority of soybean that is grown in the United States, and I'm assuming that Canada is also dealing with the 94th percentile as far as the GMO crop. All right, this is southern magnolia. It's a southern plant, doesn't grow very well up north. Southern magnolias happens to be a tree in my front yard, and it's been low nitrogen for a long time, very, very low nitrogen. So I have seen that we've had problems with this tree. It's very, very slow growing, but I do not put down NPK fertilizers. I don't play that game. But this tree for the past 10 years has just been putting out very small leaves. A lot of you have been asking about green lightning, so I thought, all right, throw in a quick slide right now. So I threw on some green lightning. Immediately, within 2 weeks, I had new growth coming up, and all of the leaves were about 4 times larger than the leaves that I had before. So here's another indication about things that you can do in order to increase the health of the plant. Not only is the leaf bigger, but you will also notice that there is a stronger wax layer on the new leaves that came up versus the old leaves. The old leaf is shiny. It does have a wax layer. It's not like it's not there. It's just that we have a more profound sheen on the leaf, which did respond to green lightning. So again, I throw that in because some people were asking about it, and they've seen some of the videos online, so I thought I'd throw that in. Root Brix is another thing. So if we're taking a look at root Brix, what's poor, average, good, and excellent? Well, poor is 4. Carrots don't taste too good with that. They also don't have a very vibrant color to them, and they're very kind of bendly. But when you get up to good and excellent, they snap. They're no longer bending as much. They have a much greater orange color associated with them, a much brighter color. And 18 is what a root would be, the carrot root would be if it is excellent. Does this mean that's the end game? No. Can carrots get higher? Yes, they can go to 19, 20, and beyond. I'm just saying that 18 is excellent. So if you can reach 18, you're in good shape. The reason why I mention this is because the roots often get higher than the leaves. Sometimes that happens. And so because of that, you need to be aware that when you're testing things, there are going to be some fluctuations when you're testing other parts of the plant when it comes to testing sugar, because sugar moves around plants differently based upon the species. Root Brix too, this is also a big deal, because when you're measuring the roots, things change during the fall. As you know, a lot of nutrition is pulled out of the roots, and as soon as it does, the chlorophyll stops, the green disappears, and it's replaced by the reds, the yellows, and the oranges of the carotenoids that are left in the leaves, and that's what we call fall, the fall colors. All of this energy and sugar is taken into the roots. So during the fall time, the leaves will go down to about 0 Brix, but the roots will shoot up, because that's what happens with deciduous trees. For trees that remain green all year long, like the pine trees, we got lots of pine trees up here. We actually have a lot of pine trees forests in Florida as well. This surprises a lot of people. They're evergreens, and they're not moving as much sugar down during the fall, but you need to be aware that sugar does move around the plants, and that you can get strong fluctuations during the fall as the root Brix goes up in these trees. Stem Brix. Stem Brix is what I talked about in regards to sugar cane. Stem Brix is a little bit of a different beast. Can you still measure the leaves? Yes. Will the leaves still be indicative using the chart? Yes. Everything is good. No problems whatsoever. However, these guys are storing sugar in the stem. This changes things a little bit. So the stem Brix becomes a little bit different. And if you're taking a look at leaf Brix, this is the leaves. The leaves are all up there. So if you're grabbing a leaf, you can knock off a leaf and curl it up and squash it and get your Brix reading, and everything is just fine and dandy. However, we also have stem Brix, which is often looked at. and we use a refractometer for that as well. In sugarcane, it's a different beast. So if we are getting a 7 to 10 Brix in the leaves of sugarcane, because of the concentration of sugar in the stem, we will be getting about a 15 to 18 Brix in the stem. Once again, it's beating the leaf. Sometimes this happens. You need to be aware of this. So when we're testing something like that, I need you to know about the differences that sometimes occur between the leaf and the root, the leaf and the stem, the leaf and the fruit. Now, if the leaf Brix comes in at 15 to 18 Brix, then we're going to be looking at about 22 to 30 Brix. And obviously, there's a lot of money involved in that because we make molasses and various other sugar forms with the sugarcane. So sugarcane molasses is a very common molasses. Unfortunately, there's a lot of glyphosate that's sprayed on it, so you need to be careful with the sugarcane molasses, but there are some organic sources that would be better. But molasses is something I love to put on. I buy the stuff and play with it at the house. And I do use the blackstrap molasses, which does come from sugarcane. So that's how the stem Brix works in there. And so you can see how much higher you can get with 22 to 30 Brix. It's very, very different from the leaf. The same thing occurs with the fruit Brix. The fruit Brix also very, very different, but not different in all cases. Just happens to be different in the sweet fruits. Apples, oranges, cherries, grapes, strawberries, the sweet fruits. There's going to be a large change in Brix in the fruit. This change can be profound, but fruit Brix in these cases needs to be higher than the leaf Brix. Can you give us a number, Tom? I'd be happy to. I'm looking at a 3 to 10 Brix jump. If I cannot get a jump of 3 Brix at a minimum, there's a problem, red flag. So if I'm getting 15 Brix from the leaf, I should be getting a minimum of 18 Brix from the orange. Okay. I've tasted a 21 Brix orange. I know that this is possible. I didn't test the tree at the time. I just happened to be handed an orange, and of course I tested it because I had the refractometer, and I'm a nerd. I mentioned that earlier on. I think you remember that. I hate to repeat it, but sometimes you just need to drill it in. My family doesn't think I'm that cool either, by the way. So the jump can be extreme. That's why I have 10 Brix up there, but you can get some large differences between fruit Brix and leaf Brix. Especially happens in grapes. Because of this, especially when you're trying to get up to 24 Brix for wine grapes, you have these large fluctuations. So you need to be aware that fruit Brix is on a different scale, and it also differs based upon what plant you are dealing with. And finally, I wanted to talk now about Phloem Brix. Phloem Brix has been a point of consternation with a number of people. The Phloem Brix, I'm just going to repeat it again, it is an extractive process. Nova is really kind of the originators. They're the ones who did it. They're based in the Netherlands. So if you want to get your leaves tested, you take the leaves off. They ask you to keep the petiole. You put them in a plastic bag. You send them off to Nova. It's usually there in 2 days. They're probably testing it once it arrives. So it's about 2 to 3 days late. A little bit of an issue with that time that it's in transit. This is another reason why I like to use the refractometer. But plant sap analysis is a different beast because they're extracting the phloem and the xylem tissue. And when you get that, you got a lot of information that is on this plant sap analysis. Many people have asked me to explain, is it the same as leaf Brix? If I see a Brix reading on the plant sap analysis coming in at 2 Brix, does that mean my leaves are at 2 Brix? No. Okay, Tom, no is strong. I get that. I know what you're saying. What about a relationship? Is there a relationship such that if I'm measuring 2 Brix in the phloem, I get a 4 Brix in the leaf? And I say, you're talking about an algorithm where you can simply multiply it or add it. Is there that type of algorithmic relationship? No. So because of this, I've had a chance to look at about 10,000 plant sap data. The relationship seems to be quite strong in my mind, and it is not related to leaf Brix. It is a different beast altogether. This is a little bit of the readout. So if you get a plant sap analysis, there are a lot of numbers that you get. And this is all an extractive process. This is now an analysis of the plant sap, not the leaf, which I'm measuring with a Brix refractometer. It's just measuring the phloem and the xylem tissue. And you get a readout of every single micronutrient. We've also got a separation of total nitrogen, nitrate concentration, ammonia concentration. So we got 3 different nitrogen readings. And we've got the big ones like calcium over here. And lo and behold, over to the right, there it is, sugar. In this particular case, coming in at 0.65. Is that related to leaf Brix? I just got finished telling you no, it is not related to it. Well, what is the deal with that? Well, when leaf Brix goes up, plant health goes up. That's what I was showing you on the chart. This isn't rocket science. I think you're all with me right there with that. Brix goes up, that's a good thing. Plant health goes up, that's a good thing too. Vascular Brix, through the plant sap analysis, when the sugar goes up, health goes down. Is there at least an algorithmic relationship to, one goes up, the other goes down? Is there a formula you can give me? No. I'm just going to tell you. Your blood is tightly regulated. If your blood varies, if your pH goes a little too high or a little too low, you're dead. It's important to keep your blood tightly regulated. Same thing with the plant. Because there is a tight regulation in the phloem and the xylem tissue, it is not open to this type of study, the Brix study that we do. Because it's tightly regulated, we are looking for about a 2 to 3 Brix inside the vascular tissue. That is now what I have learned through looking at about 10,000 of them and looking at many different crops, cotton, strawberries, soybean. You can see the relationship. I'm looking for a 2 to 3 Brix. If I'm getting low, like the 0.65 that I just showed you, I know there's a problem. There's not enough sugar that's moving around the blood system of the leaf. And if it gets too high, that's also bad. Too much sugar in your blood can also kill you. This is where, in part, where diabetes comes from. You can have a little bit too low, you can have a little bit too high. It needs to be tightly regulated. So because of that, this changes things. For example, let me show you some data, because this is stuff that you guys just love to memorize. But this is based upon a huge number of data points. I've got sugar going up in a plant from 0.6 all the way to 10 Brix. What happens with cobalt? Cobalt raises, it goes up when the plant starts to get healthy, and then the cobalt levels decrease. So as the sugar levels get high, the cobalt levels are decreasing. This is not a healthful situation. Same thing occurs with molybdenum. Things are okay at the beginning with low amounts of sugar, and then as the sugar gets higher and higher, the plant is more and more unhealthy. We get decreasing amounts of molybdenum. Allow me to continue. Copper. It raises as it should when it's low, and then it starts to collapse again. As the sugar gets higher, the copper levels are getting lower. The plant is getting more unhealthy. You know where this one is going, and this one is now about nitrogen. When the sugar gets too high, the nitrogen levels go down, and the plant becomes compromised. This is all in the same crop, by the way. I'm just giving you a little bit. I decided to put up 4 graphs right there because I needed them big enough. I didn't want to show you 22 graphs, but I wanted to make a point, is that when you see high sugar in it, if you are getting a plant sap analysis, and sometimes you do, the high sugar is indicative that there is a problem. So here we have some data right now. This is actual data from the same crop plant that I just showed you. I've now got sugar at 9.2. It's too high. Immediately, I start looking down at all the numbers, and I'm looking for a deficiency. Here, we see it. There's no cobalt. It's not even 0.01. It's 0.00. The plant is starving to death. It is absolutely deficient in cobalt. The others aren't looking too good either. Molybdenum and copper are low. Nitrogen looks pretty good. But as you continue looking, I looked at all the figures that were high, all the 9 Brixes and the 10 Brixes. And you scoot over and you will see deficiencies. There's cobalt, 0, 0, 0. There's 4 different points. The rest of the time, it's all low. Molybdenum, all low, below what it should be. It shouldn't be less than 0.42. We're dealing with a lot less than 0.42. I mean, a huge amount. The plant is starving to death. Copper, every single level is below. We should be between 1.6 to 3.5. Everything except for 2 are below 1. I'm dealing with a copper deficiency. Immediately, some of you are thinking like, whoa, hold it there, Tom. We do have enough copper right here, 1.96, 1.96. Therefore, the plant is healthy. Huh? I'm paying attention to what you're saying. Is it? Let's take a look at this copper levels, which are high enough, and scoot over, and you see you are deficient in cobalt. You're at 0.00. Our molybdenum levels, 0.07. So it's not a matter that everything is deficient, but when I see high sugar in a plant sap analysis, I know that the plant is deficient. What is going on physiologically? The plant realizes it's starving to death. And it starts emptying its storage of sugar and starts dumping it into the phloem tissue and exuding it into the root system. Will that kill the plant? When it's removing that much sugar, it will. But right now, the plant is figuring, and it's right, gonna die anyway. So I'm just gonna start emptying all the sugar I have, put it into the roots, get some microbes to come to the roots and get the cobalt that it's missing. Get that molybdenum that it's missing. Get that copper that it's missing, and so on and so forth. The process continues. That's what you should be looking at when you see a plant sap analysis, because these deficiencies are real and they're very big. So this is now starvation conditions. It's a higher Brix on the plant sap analysis, but it's a starvation condition for the plant. Take-home message, leaf Brix is not the same as the phloem Brix. That's the take-home message. And so that chart works great for leaves. But you now have a broader background of sugar. I've taught you a little bit about the types of sugar. You know how photosynthesis makes glucose. You know that sucrose is the storage form. You know that sugar makes the plant in cellulose. You know that sugar is required in order to be moved around the plant in differential abilities based upon the species. I have educated as far as I can in about the 1 hour that I have in order to present. And I'm going to check to see, yeah, we're about 1 hour right now. I wanted to make sure that you were as educated as far as possible in 1 hour. I could go beyond this, but you're all going to start falling asleep. I realize that this is about the limit. This is about as much as you can get of Tom Dykstra. At this point, you want someone else to come up here so that you could look at someone else, possibly better looking, maybe a little bit more exuberant, so that you can get the additional information that is provided by some very smart people here. So I put this up here just that one last time so you can see that. I would like to thank you for putting up with me not just once this morning, but twice, because you had to put up with me yesterday, and now you have to put up with me again. I would like to thank you for staying awake, mostly. I would like to thank you all for giving me the time to speak to you. I would like to thank you for listening to me, because I've also had complaints that I should not be talking to farmers. Serious discussions, to the point where one of the companies that I was working for was ready to fire me, and eventually they did, because they did not want me talking to farmers. And I've talked before, and I said, why can't I talk to farmers? I talk to them all the time. And they said, no, you don't talk to the farmers. I said, who's going to talk to the farmers then? He said, that's what the county extension agents are for. I said, I see. So the PhDs are not allowed to talk to the farmers? No. We leave it to the county extension agents. Right. So you just need to stop talking to them. We'll take care of it. They get their information from us, the other PhDs in academia. You are not qualified to talk to the farmers. Therefore, you are bypassing our mechanism right now, and you need to cease and desist. I had to go all the way to the CEO for one company, in order to get permission to talk to farmers. So when I say thank you for allowing me to talk to you, know that I mean it. This is not just some word that I'm spouting out right now. Thank you. Thank you for listening to me. Thank you for giving me the opportunity to talk to you so that I can bypass any false information that you might get, you might not, from someone else, like a county extension agent. We have county extension agents in the United States. Do you have county extension agents here? You don't have them? Okay, those are the go-betweens between the doctors, the PhDs in the offices, and the farmers. It's the county extension agents. So now that I know you're not aware of that, I realize some of you from the United States and you get the system, but I'm hearing now that Canadians don't have that, so it's a little bit different. So I think I'm just going to stop talking right now. I don't know if we have time for questions. If we do, I'd be happy to take a shot at them. I'm happy to answer any easy questions. Any hard questions, I'm going to divert to Lauren, and then Lauren will answer all of your hard questions.
We are actually shocked, Tom, that you have left us a half an hour for questions. So
What?
we are got a half an hour of time yet.
What? I thought I had an hour. I've been talking for an hour. How much time did you give me?
An hour and a half.
For this presentation? I should have put more slides in.
So we got lots of time for questions. So I just want to open it up. I'm sure
Okay.
lots of questions.
Oh, my.
We'll keep Tom on the hot seat.
Yeah.
We can ask the questions from the mic.
Questions are harder to answer than just throwing a few slides in, so.
If we can ask the questions from the mic, so just so that everybody can hear.
Yeah, please ask from the mic simply so that it can be recorded. And then you guys apparently are getting a recording of this, but just everyone in here. It's not going to be universally available, I am told. Go ahead.
Thank you, Thomas. Excellent presentation. Always a pleasure to listen to you. Makes us grow up, I think. And
Grow up.
yeah.
Before I talked, you were kids. Now you're adults. Hello, fellow adults.
My question is, I mean, when I go to the food store purchasing apples,
Yes.
I give the apple as example.
Yeah.
There are different varieties.
Yeah.
What's the relation when I choose a variety? And I see that in my corn as well, which planting and the crops.
Unfortunately, we can't test leaf bricks in the store. So when I go into the store and we're bringing the stuff home, I usually have to test the stuff that I'm given. So yeah, you have to test, you can test the corn, you can test the tomatoes, you can test the apples, the oranges. You pretty much have to test the fruit. Because I'm aware of some of the fluctuations that occur with fruit bricks, I can usually get a good idea because I know what a good orange is. Like I said, I've eaten a 21 Brix orange, and so that's what I'm looking for. The apples, yeah, really shouldn't be below 18. It's very hard to find something even at 17 Brix. Some of the apples are going to be even below 15 Brix. And as they get lower and lower, they start to not only taste bad, as you test them, you'll see that they're low Brix. And you're about to say something in just a second. Not only are they low Brix, they don't taste good. And as soon as you bite into them, they start to get brown. That's because the antioxidant levels are so low that it starts to oxidize immediately. So I've bitten into apples before and watched it turn brown in 20 seconds. Other times you can cut open an apple and leave it on your table, and you'll get virtually no browning in 30 minutes. Just a little bit of browning here and there. That's a good apple, has a lot of antioxidants. So there are ways to measure this stuff. I'm going to say one more thing before you ask your follow-up question. I have tested tomatoes before. The best tomato I ever got in a store is 5.2. Go ahead.
So more precisely, what's the difference then? Let's say I purchase a Macintosh versus a Spartan. I would say, I don't know, by my heart, but let's say Spartan is more sweeter.
Yeah, there are differences in the varieties of apples, and they simply have to be tested.
But what's the mechanism that makes it different?
Oh, the mechanism? Well, it's a complex physiological mechanism that is above my pay grade. Meaning, I don't know how all of the sugar gets in there because it's dependent upon the particular apple tree. So let me give you a little bit of insight. Since I'm not able to answer your question, I'm going to try and answer your question by going around the question. And that is, there's a story right now. It's from Bob Pike. He went into a store and he went up. He said, "Can I see the produce manager?" And the guy was like, "Yeah, I'll go get him." And so the produce manager comes out. And of course, he's thinking like, "Oh boy, here we go." And Bob says to him, he says, I'd like to buy some apples. I'd like to buy a lot of apples. He's like, oh, well, I'd be happy to help you. He says, I'd like to buy some apples that are above 16 Brix. And if they are, I'd like to get a whole bunch of them. He's like, well, absolutely. You have good apples, right? I have the best apples around. So he pulled out his refractometer and they went through and they started testing all of the varieties of apples, all below 16. And the produce manager was getting uncomfortable because his apples were not up to snuff. And so they were all below 16. And then they got to a variety. This happened to be Fuji. There were Fuji apples. At the time, Fuji apples were new. They hadn't been messed up yet, okay? So it was a fresh one. The Fuji apples came in at 19. Produce manager was happy. Bob Pike told him, he says, not only will I take an entire box of this stuff, but I'm going to pay you more than you're asking for. I think he paid him $1 an apple, if I recall. And so this is the type of story, is that he took matters into his own hands. The produce manager was there. He got permission to start tearing apart apples in front of everyone in the store, and he got what he wanted. Bob said when he brought those apples back, his grandchildren, Bob Pike has since passed away, if you're not aware, his grandchildren were asking for the apples after school. They used to ask for candy after school. They were now asking for those apples. That was a number of years ago. Fuji apples are no longer at 19 Brix. And so these varieties that are being discussed right now, when you get a new variety, people often say, oh, this is so much sweeter than the other apples. And it usually is, because it's a variety that hasn't had a chance to be adulterated yet in various ways. And so that's why it came about. So Fuji, when it first came out, good stuff. It's the same way with a lot of apples. Some of the apples, when they first come out, if you test different apples, I'm not a big Macintosh fan. I'm not a big Red Delicious fan. I kind of like the green ones myself. I think they're a little bit sweeter. Obviously, I'm looking for sweetness because I know it's going to be higher Brix. But those are my preferences. People have different preferences. People, I know, don't care about the sugar. They just want their Red Delicious apples, and that's the only one they're going to get. That's fine and dandy. They just don't make my skirt go up. Okay, so I don't really like them. But because we have these different types of apples out there, one, it's based upon your taste preference, because some of them will be more acidic than others, and the sugar preference as well, but it's also your personal preference too. That's why we have so many apples out there. And we do have some different oranges too. We have Valencia oranges, we have Hamlin oranges, we have Satsuma oranges. It's the same type of thing, Yes,
Thank you again. This was a treat listening to you again.
thank you.
I have 3 questions.
3, I'm sorry, we can't do 3 questions. Cindy, is there a quota for this? You're going to let her take the 3. All right, ask your 3 questions.
So-
She knows I got a half an hour. That's why she's got 3.
Do the plant release less exudates as the soil betters itself?
As the soil what?
As the soil improves.
Is
Is that a myth? Is that
No. They actually release more. The more Brix, the more exudates are released, because the plant will release only as much as it's comfortable doing. Now, there are those exceptions that I told you about if it's in starvation conditions. If it's in starvation conditions, it will completely empty as much sugar as possible, and then it dies. This is the reason why many grapevines, many people are like, I've had this in generations, this has been around for decades, and suddenly the vine dies. These vines are dying because they're emptying themselves of sugar, and it's killing them because they're trying to get nutrients. So under those conditions, it's a little bit different. But generally, when you've got a good, healthy Brix tree, so let's just say it's 16, so it's doing very well, and I can get a 16 Brix on almost any tree right outside my laboratory, by the way. If you just are dealing with like a 16 Brix, it's usually got plenty of sugar, because it's putting about half in. It's putting about 8 Brix of sugar, give or take, into the soil every day. That's a massive amount of sugar. When you've got a tree that's coming in at 6 Brix, that's only putting in 3 Brix into the soil, because that's all it can afford. Therefore, generally speaking, if you have a higher Brix plant, generally speaking, the soil is going to have more sugar in it, more microbes, the soil is healthier, the plant is healthier, everybody's happy, and that's usually how things work. I was only talking about an extreme situation, starvation conditions. And I even fielded a phone call one time from Cindy a few years ago about a grapevine that was, I think she said 5 Brix on the leaf, and it was well over 2024, and the plant was about to die. So the grapes were getting up there. They were getting over 20 Brix, but the plant was about to die. And so the plants can do this. They can kill themselves making fruit, and then that will be the end of them. That's not what they want to do, but that's what sometimes happens. So I'm hopefully answering the first question. I'm worried about the next 2.
Does the sugar content in a sap analysis changes as much as in Brix?
Oh yeah, that does not change that much. Most of the sap analysis that I've looked at were between 2 to 3. The variation is just what you would expect. There was some variation at 1 to 4, but it was rare to find something at 5, 6, 7. But it's not that hard to get 5, 6, or 7 on a leaf Brix. Therefore, the variability on a plant sap analysis or the Phloem Brix is very tightly regulated. That's what a healthy plant will do. It doesn't mean, because you say, well, I don't understand why there's only 2 Brix going throughout the plant. Well, that's because it's trying to regulate its blood system. The rest of the sugar, if it's high Brix, is going to be stored. It's going to be stored in the roots. It'll be stored in the leaves. It's just being stored. Anything that's moving around a plant is going to go into that superhighway system that we call the phloem and the xylem. That moves things up and down the plant very efficiently. And so at that point, they do not want to change that too much. Now, there is a slight jump, trying to answer your question as fully as possible, is that during the nighttime, you will notice on the plant sap analysis, there will be a jump. If you take the leaves at night or right around dusk, there'll be a jump in sugar because the plants that I told you start to dump their sugar into the soil at night. And so therefore, you usually get a bump. Usually in the plant sap analysis, we are told that it needs to be about 9 o'clock in the morning. So for consistency's sake, it's done at 9 o'clock in the morning, and that's all fine. So at least we've got that. But do understand that the plant Brix readings will change throughout the day, and one of them is a nighttime reading, because as the sugar is going down into the leaf, sometimes you'll get a slight bump in sugar because it's moving down, doing what a plant does naturally. So hopefully this additional information is helping you and not confusing you.
It's helping.
Okay, third question.
Third question. There are these Horiba instruments out. It's a handheld sap analysis tool.
Yep.
What's your opinion about that?
Horiba is a brand that I've used before. I have no difficulty with them. Horiba, do they have a plant sap? They don't have a plant sap analysis meter.
No.
Horiba doesn't have that. They're looking at things like pH
Yeah.
and some of the other things, but they won't be measuring plant sap analysis. That has to be in a laboratory with very expensive equipment, which is the reason why it's costing almost $100 a pop when you do that, because it's very expensive to do it. But those handheld instruments are usually measuring other things. Those are fine. We've used them before for testing pH. So oftentimes if I'm squeezing leaves to get a Brix reading, because I'm using a plant sap press, I get a lot of juice from it. The garlic press doesn't give me enough, and I prefer to use a plant sap press. And so we've got so much left over, we can have a whole host of meters lined up on the table and still have enough drops in order to do a Brix reading, and then a pH reading, and almost any other reading that you want as you go down the line. So those are all fine, and they all have their place when you are doing that. And that's additional information right there on the spot that you can learn from your plant, rather than sending it off for 2 days and waiting for it to degrade in the mail, which of course it does.
Thank you.
Thank you. Thank you.
Thank you for the information.
Thank you.
Is there a relationship we could make in wheat with the sugar content of a plant and the protein level or quality?
Okay, all right. I'm not aware of the relationship. I haven't looked into it. So is there a relationship? Of course there is. There would be a relationship because protein is looked at in regards to wheat. Wheat is usually, most of the grasses are pretty high. They have a tendency to be a little on the high end as far as Brix. And that's why, sugar cane, corn, and some of the other stuff can often be a little bit higher Brix than some of the other stuff. But as far as the protein is concerned, I just personally haven't looked at it. So I just don't know. I'm aware that there's protein analysis which is being done, and of course that's reflective of it. But as far as a clean relationship between them, it's probably there. I just am not aware of it right now, and so I'm just showing my vulnerabilities right now to you all. All right, Mr. Organic Jam, hit me.
I have a comment before the question.
Oh, okay. So I can have a seat then while you just.
Yes, there is a way to test Brix in the store. You know, when I met my wife, her bunny had just passed, but before we got together, she used to take her bunny to the grocery store in a bag, and as she would go in the produce section, she would put the produce in front of the bunny.
Yes.
Turned its head, she put the produce back. If it went for it, it would go into the basket.
Very sensitive Brix refractometer right there. Very sensitive.
Someday we'll have Brix on the label.
Now, I should point out that the Brix refractometer is a little bit smaller than a bunny. A little bit lighter. You could probably be a little bit more covert in the store with a Brix refractometer rather than having a bunny underneath your arm. But I love that story. Thank you.
And my only question was when the few times I don't do this very often, but if I'm doing leaf analysis, we do take the refractometer out there. We'll peel the leaf away and just test the stem.
Yes.
Is that? I don't know why I do that. Someone told me to do it that way.
Yeah. You will get a different reading when you do that. So the stem is sometimes what we call the petiole. So let me give you a complete understanding of the petiole. When you send it to NOVA, anytime, they're doing a plant sap analysis, they want you to keep the petiole connected to the leaf. That makes it easier because they're attaching to the petiole and they're sucking out the phloem and the xylem tissue in order to do the plant sap analysis. So that makes sense. I cut off the petiole. I never use the petiole in a measurement because if you take off, you can get 30 leaves and get a measurement, but if you take 30 petioles, then you're just getting that which is moving throughout the plant. You are more accurately getting a phloem and xylem tissue, plant sap analysis type thing, because there's very, very little sugar stored in the stem. There's some of the stems are green, which means they have chloroplasts and they're photosynthesizing, but it's comparatively small. What this means, and this should make sense, the Brix readings are always, always, always less when you measure the stem. So if you're measuring the petiole, that's a completely different beast. The Brix readings are going to go down by necessity. And because of that, I don't test them. That would require a different chart. There would be a little bit closer relationship with that in plant sap analysis because all they do is the phloem and the xylem. I want to take a look at the entire leaf, that which is stored in the leaf, whereas the petiole will give you a little bit better understanding of that which is being transported at that time through the leaf. So for example, if you didn't want to send it out, you can measure the petioles at night. And that's where you will notice a jump in the Brix because the plant's getting ready at night in order to start throwing sugar down, and therefore you will start to get a jump in the Brix levels from the petiole. So I don't use the petiole. You can use that. If you do and you have enough data, it's time for you to make a chart. And then we're going to get you up here, and you're going to get up there with the petiole Brix chart, and we're all going to be super impressed, and I'm just going to scratch my head thinking, what is he doing this for? And then you're going to come up with all these great ideas that come from petioles that I'm not doing right now.
Yeah.
So I've abandoned the petiole. Some people like to include it in a Brix. I do not because I know that it's going to lower my Brix readings, and I want the highest Brix reading of the plant. I want to know what it's doing at its optimum because sadly, sometimes I give these plants the best shot in impressing me and it comes at a 2 or 3 Brix. And I'm thinking, oh wow, man, I gave it all the chances. I'm here in the afternoon, the sun is out, and this is all that it's given me, 3.3 Brix. How pathetic. So that's why I don't use the petiole. So it's up to you.
Yeah.
If you want to do that, you're off on your own. That's your own pathway.
Yeah, thank you very much, because I was looking at your charts going, I never get a 12 out of the petio,
Yeah,
we're,
yeah.
get 8, we're doing a dance.
I think you'd have to get like 18, 19, 20 bricks in order to get a 12 on the petiole.
Yeah.
Because there's just not that much going around it. So yeah, I don't think you're gonna get that. But
Thank you so much for being here. It's my first time meeting you. This has been fantastic.
yeah, I know it's like I've known. I mean, I've known Dennis so long, as I told you. So
yeah.
I feel like I've known Organic Gem for a long time.
Mm.
I was really embarrassed because I went up to him and I said, "Oh, you're with Organic Gem." I said, "How long you been with them?" He goes, "I'm one of the founders." It was just one of those embarrassing moments, you know. And at that point, I'm fumbling for my words. Yes, of course. Of course you are. Of course you are. Yes. All right, Howard. Whoa. Oh, boy. This can't be good. Oh, it's good. Awesome. You're good.
There, can you, a little off topic, can you address the difference between tissue tests and the SAP tests and what kind of numbers they're
Yeah.
looking? Because
Yeah.
we're going further that way now as the soil gets better so if you could just address that, thank you.
Yep. Okay. The tissue test is another beast. Okay. We have the Brix test. That's where you crush the entire leaf. You just get the liquid, and then you measure it. That's great reliability. If you do the plant sap analysis, that's very accurately telling you that which is moving around the plant. Okay. So that is its own beast as well. The tissue test is essentially crushing up things like I do for Brix, but it analyzes everything. Not just the liquid part, but the solid part. And so that can be important. I like the plant tissue analysis next to a plant sap analysis. Why? Because this tells me what nutrients are stored in the plant, tissue analysis, and those nutrients that are being moved through the plant. So sometimes when I've got them next to one another, I can see, all right, there's a lot stored over here, but nothing's moving through the plant right now. Or sometimes I see a lot of movement for a particular nutrient, but it's not being stored. And sometimes you see a little bit of both. You're looking for this relationship. So just know that when you do a plant sap analysis, or really a petiole analysis, you are essentially looking at the nutrients that are on the move. They're trucking. They're moving around the plant, doing their moving thing. That's what you're testing with that. But there's also an importance of testing that which is stored in the plant. The Brix refractometer measures what is stored in the leaf. And the tissue analysis lets you know what is stored in the leaf, the stem, the root. You can do a tissue analysis of anything you want. This is all additional information. So, I mean, if you hand me Brix information, plant sap analysis information, tissue analysis information, throw in a soil test in there too. Kind of want to see, I mean, this really gives you a more complete picture because you take a step back and say, all right, what is the plant doing? This is what's available in the soil. It's not ending up in the plant, therefore we got some bioavailability issues. This is moving around the plant. It's not being well stored. It kind of gives you an idea of what you need to do in order to help the farmer, which I'm not allowed to talk to help the farmer and let them know what some of the problems might be with their plant and how they can overcome it. So for example, if not enough sugar is moving around the plant, I think a lot of you know this already, there's sometimes a boron deficiency. Boron is an elevator. It helps move sugar up and down the plant. It often attaches to boron. And so sometimes if sugar is not moving around the plant, it's not distributing itself the way that it should, there's usually a boron deficiency, and that's partly why you get the hollow stems. If you've got a stem which is not hollow, it usually means you have enough boron. So there are all these little signs that you can do by taking a look at the plant and then having some of that data. So all of it has value. All of it has value. I don't disqualify any of it. I can tell you, and I know Glenn feels the same way because we've had many annoying conversations with one another, and that is when you get handed a soil test and only a soil test, and you get 3 to 4 years of soil test and only soil test, and that's all you have. So you're just looking at the soil and nothing else. There is a massive amount of information that is not there. And so because of this precisely ambiguous data, you're getting exact figures that are not really helping the situation. I want to know what's going on in the soil. That's good to know. But if that's all you've got, you're missing the picture. I want to know what's going on above the soil too. And that's why we have the Brix. That's why we have the plant sap analysis. That's why we have tissue analysis. And that's why we like to play these games so that people who are data hungry, like me, can start to make sense, at least to the best of our abilities based upon our limited intelligence, in order to give advice to the best of our abilities. Okay? How are we doing? We got another question coming.
Sure.
We're not done yet, Lauren.
On your closing chart there, you said once we get to 12 on the leaf bricks, disease and insect immunity.
Yeah.
Do you have any more information on, like, you have the thresholds for all the different insect groups? Like, what about diseases? Do you have some different threshold information?
Yeah, I am an entomologist, and so because of that, I don't have all the data, but Glenn and I were talking about that just a few months ago. And we were noticing, we had some close figures, is that he noticed that once you get to 8 Brix, you don't have fungus infections. I was telling him I haven't noticed anything at 10. And so this is not a matter of right or wrong, although if you have to side with one, I would side with Glenn on this. Glenn is one of the smartest people I know. No, I'm not going to repeat that. And so because of that, he has seen more than I have. So essentially, if you take both together, if you're in that 8 to 10 range, you probably are not going to need fungicides at that point. But if you are clearly below 6, both Glenn and I are going to tell you, you are susceptible to fungus now. As a matter of fact, you're susceptible to just about everything at that point, aphids included. And so because of that, the fungus, which I don't pay attention to as much because of my background, I'm more interested in the 6-legged figures we call insects. I'm interested in physiology of the plant. I don't look at slugs as much. I don't look at although I did answer a question yesterday, I struggle through the slugs because they're a mollusk and they're related to the octopi. What do I know about the octopus? You know, come on. And so because of that, I'm a little off the beaten path. I can tell you this though, since you asked about disease, and that has to do with citrus. When I have a citrus plant at 9 Brix, there are no Asian citrus psyllids, and there is no visible evidence of citrus greening. Okay, it's there. It's been found in probably about 100% of the citrus trees in Florida. Probably. If it's not 100, it's probably 90 to 95. So it's about the plants being able to handle the disease. If I had to look hard enough, I could probably find a rhinovirus in every single person in this room, including me. Whether or not you have a runny nose right now is irrelevant. I could probably find a rhinovirus in every single one of you. You may not be exhibiting the symptoms of a cold or a runny nose, but I could probably find it because most of you are we're fighting off disease every day. Plants are doing the same thing. They're fighting off disease every day, and sometimes you can have disease running through your body or the plant tissue. You just don't show the effects because the immune system is able to take care of it. So I'm not worried about citrus greening when it's at 9 Brix and above, of course. The fungicides become unnecessary when the plants get healthy. The insects are a little bit higher, and when they do that, we've got different readings for them. So I'm about as far as I can go with this information as I can. So now it's just a matter of, developing more data and looking to see if I can make more connections. And if I ever get invited back, Cindy does have her tolerant levels though, then maybe I can share any new information. I know she's like, you reached it, Tom. Yeah. You know how close you were before? You're there now. All right, any more questions? Yep, Lauren is moving in for the kill right now. I can see him. All right, thank you so much.